right, here we go, guys. All right. Now, yesterday, and in the past, we've only had variables on one side. Now we have variables on what? Both sides. So you just have to learn a technique to figure it out. All right, and let's do that real quick. Let me show you. All right, very, very simple. At the top of your iPad, you should put an equal sign. All right, here's your equal sign. And then, what does that mean? Variables go on the what side? And numbers go on the what? When you move something, you have to change signs. That's how simple this is. All right, it's very simple. All right, so again, I want to try to move the variables to the left. I want to try to move the numbers to the right. All right, so let me show you exactly what that means now. Look how simple. All right, blow up on number 1. Now, this, just to make sure you understand what I'm saying, this above is a variable. This right here is a number. This is a what? And this is a what? Number. Now, when you're looking at it, someone once showed me this. I don't do this, and I don't want you to do this, but I'm just showing you. This is the what? The left side, and this is the what?
Right side.
That's the right side. Everybody agree with me? I want to be on the left side, and I want to be on the right side. And when I say left and right, I mean left and right of the what? Equal sign. That's all it's asking. All right? Very simple. Okay? So now, what I do is, normally, I'm going to erase this now. All right? Now, normally what I do is I ask you this question. This right here is, again, a what?
Variable.
Is it on the correct side? Yeah, so I don't have to move that. Now I have this -6. Is it on the correct side?
No.
No, so I have to move it to the other side. If I move it to the other side, I would do what? I would add 6. Now, why would I add 6? Because it cancels out. Thank you very much. So I'm going to put a +6. Now, why do I put a +6 under the +9? Because you're putting numbers with numbers and variables with variables. All right, is everybody agreeing? So now I'm going to ask you now to look at the x. Is that on the right side?
No.
No, I need to move it. So if I move it, I have to make it a what? I have to make it a -x. That is correct. -x and -x. Now you can look at the 9. Is the 9 in the right spot? Yeah. Come on, guys. Does everybody see how simple that really is? I'm just moving things around. I don't understand why this is hard for kids. All right, because that's the only rule. Variables go on the left, numbers go on the right. All right. Now, generally the mistakes that are made is people forget their rules for adding and subtracting. So what's 4x minus 1x?
3x.
3x is equal to, because what happens to the -6 and the +6? But what happens to the x and the -x?
They cancel out.
And what's 9 plus 6?
15.
15.
With 3x.
Come on, Aiden.
X would be 5.
Exactly correct.
Oh, that's actually.
Because now, how do I undo a what? You get it right?
Yeah, I did it a different way. I did 4x minus 1x, and I got 3x, and then -6 plus 9, and I did plus 6 minus 7.
That's exactly correct. All right. Now, this right here, though, is how I want you to be doing it on your paper, though. Yes, sir.
So for number 1, how did you you minus the x even though it was positive like the x minus x?
Yeah, so this, what I try to tell kids, and try to listen to me now. I try to tell kids this is not in the right spot. Do you agree? I want variables on the left side.
So if it's not in the right spot, you just cross it
Yeah, well, in order to cross it out, though, you have to move it. And when you move it, you do the opposite.
out.
All right, now let's just look at number 3 now. All right, we'll just go down the page. All right. So I want you to do this. Is negative 4x in the right spot?
Yes.
Is the negative 3 in the right spot?
No.
So how do I take care of a negative 3?
It's the plus 3 under.
Plus 3. Do you understand why I'm doing plus 3? Most kids do not. That's why I'm asking. No, to cancel it out. Right? So if I put a plus 3 here, what does that do with the minus 3? You agree with that, right? So if I do plus 3 here, you see that now? Right? Now, is negative 6x in the right spot? No, it has to go on the other side. So if it's a negative 6x, how do I move it? That's how simple it is. Plus 6x plus 6x. You agreeing with that? Now, again, I like to just demonstrate by crossing out, crossing out. All right, I don't think that step is necessary for you to put an X on your paper because sometimes it just looks bad if you do that. But now, what's negative 4x plus 6x?
2x.
2x. So 2x is equal to what?
12.
12.
And then x would be 6.
And then we divide both sides by 2. And so x is equal to 6. Justice, you okay back there, buddy? Good? All right, thank you. Anybody have a question so far? Nope. Number 5. Here we go. Is 5x in the right spot? Is negative 7x?
No.
No. So what do I have to do? Positive 7x. Is the 6 in the right spot? Yep. So that's my only step this time. So these guys cancel. So what's 5x plus 7x? 12x. Now, everybody put a star by number 5
Yes.
because everybody makes a mistake. So what does x equal, guys? What does x equal, girls? Most people say the answer is 2. But the actual answer is, now I prefer that you write it as a fraction.
So 1
1/2.
half.
Because now watch, look up here on the board. Here's what I'm trying to tell you. It looks like it should be 2. But we're isolating the variable, so we divide by 12. You see what I'm saying, guys?
Yes.
And so x is equal to, now it's just reducing a fraction. 6 over 12 reduces to what?
1 half.
1/2. Everybody happy with that? 1/2 is perfect. All right. If you put 0.5, it wouldn't be wrong. It's just we deal with fractions in math. Fractions are easier to work with. That wasn't hard, right? All right. Let's go down here now. All right. So I see a distributive property, correct? All right. Ava, tell me how to distribute, which is 24x. Yep. Yes, ma'am. Good job. Now everybody highlight this one. And in math, we call this an identity. Why is it called an identity? Because when does 24x minus 30 equal 24x minus 30? Always. Does everybody hear me now? Listen to me. Always. All right, I'm going to show you something else in a minute, but I want you to see. Can everybody see that's identity? That's the same thing, right?
Yeah.
So in math, we say that it's all real numbers. Now look how I'm writing all real numbers. 1 mark, then you make an R. That's the symbol for all real numbers. Now what does that mean? That means no matter what number I plug in, it's going to work. Everybody hear me? No matter what number I plug in will work. If I go back to number 5, what's the only number that I can plug in to make sure that's a true statement? 1/2 is the only number that will work. What will work for number 3? 6. What will work for number 1? 5. Can I pick any other number besides 5?
No.
No. On number 7, what number can I pick?
Any number.
Any number and it will work. Any number and it will work. It's called an identity. Now, how do I know it's an identity? Because I read the problem. 24x minus 30 always equals 24x minus 30. Now, let's say you forgot. So here's how you're going to remember this. Now, if you forget, right, you're going to subtract 24x, add 30, and what happens? Everything cancels. You get 0 equals 0. And I try to tell kids that is a what? That's a true statement, or you're right, that is an identity. 0 equals 0 is an identity. Is everybody with me on this? All right, so that's an important one. That's why you highlight it. All right, now we're going on to number 9. Now, this right here, everybody should look at that a little funny and say, how is 2x plus 5 equal to 2x minus 3? Is that possible? You should be able to look at that and say it's not possible. Now look up here so I can tell you something. All right, now here's where I'm just trying to make you smarter with numbers rather than just understanding math. If I take a number and add 5, is that ever going to be the same as if I take that same number and subtract 3?
No.
That's not possible. It's like saying if I take 10 and add 5, and I take 10 and subtract 3, is that ever going to be equal?
No.
Never, ever going to be equal. All right? So this, you should look at and say, that's no solution. All right? You should be able to look at that and say, no solution. Now, let's say that didn't register. Now you can, I'm going to show you how you can see it's no solution. If I move the x, this would be minus 2x, minus 2x, minus 5, minus 5. Well, what happens over here? Cancels, cancels. So that would be 0 equals negative 8. Is it possible for 0 to equal negative 8? It's not possible for 0 to equal negative 8. Now here is what we write. We write no solution, but in math, of course, we have an abbreviation. That's the symbol for no solution. No, you can just write the symbol if you want. All right, that's the symbol for no solution. All right. Everybody good with that? Yes, sir. If it comes out to be a false statement. This is considered a false statement. Does 0 equal negative 8? No. You with me? Now I need you to look up there because I think it's important for you. You get it? All right, moving on. Let's check out number 11. All right, here we go, guys. Give you a second. 30 seconds. See if you can solve this one. Did you get an answer? What'd you get? 10, 10, 10, 10. All right, guys, I'm pretty happy with that. All right, I'm not saying that's right, of course. All right, especially if Carter gave me an answer. All right, so I'm going to double check him. Well, definitely I'm checking now. Definitely. Negative 8x, minus 7. That's what everybody should have on your paper right there. And look, come on, that's easy now. All right, draw your line underneath it. Negative 2x equals negative 20. Wow, look at that. You got one right. So x equals 10. Now I'm expecting you to kind of see the division. Do I want you to put divided by negative 2 anymore? No. You should be able to see that at this stage of the game. Well, x has to be 10. This is the important step right here. And this is your final answer. Everybody good? That's not that hard. All right. All right, let's take a look at 13. Uh-oh. Now in 13, I have a double what? Yeah, you got to distribute now. All right, take your time. Distribute properly, please. Now look up and see if you did the distributor properly correctly. If you don't do the distributor properly correctly, then there's no point in going on, right? Everybody got that? Any questions? Aiden, how are you doing back there today? You good or not? All right. Now, first step, I need to do what? After we do the distributor properly, what do I have to do? Tell me.
No, you have to, you add 32.
Yes, perfect. Add 32. Now notice I'm putting the numbers with the numbers. All right, now somebody else, what do I have to do? Aiden, what do I have to do? Very good, buddy. You add 9x. Thank you. Very good job. These cancel. These cancel. 8x and 9x makes 17x is equal to
38.
wow, 38. And so now my final answer is equal to the fraction what? 38 over 17. They make good with this.
Oh, you just make it a fraction.
Just leave it as a fraction. It doesn't reduce. No, leave it as that improper fraction. That's correct. That wasn't that hard, right? All right, let's check out 15. All right, now we have to go back a couple days. I need you to put yourself a note. Combine like terms. Don't forget that step. Combine like terms. So Jack, what do I have to do what do I mean when I combine like terms?
You like add negative 2x and negative 3x.
You said it perfectly. Highlight the negative 3x and the negative 2x. That's why I like notability. You can make yourself notes. All right, so you can write on there. Make sure you understand what I'm saying. That way when you go back and look at your information, you can remind yourself how to do it. So what happens when I do that? What do I get?
Negative 5x.
Right, so you're going to write negative 2x is equal to negative 5x plus 12. Now what do I do from there, buddy?
Oh, well, you could put plus 5x under,
That's right.
and then you put minus 12 and negative 12 under.
No, sir.
Oh, yeah, I was thinking different.
Right, because the number's on the right side. Do you agree?
Yeah.
So now what do I get?
So you would get 3x is equal to 17.
How are you getting 17
I
from that?
did it wrong.
3x equals what? Tell him. 12. Thank you.
Yeah.
3x equals 12. Now, how did I know it was 12? Because I'm looking at the number right there, and it says 12.
Yeah.
Right? And so now, obviously, what?
X is equal to 4.
X equals 4. Come on, guys. Getting a little better as we go down the page. All right, good job. All right, let's talk about 17. What do I do first? Tell me. Go ahead. Yeah, but on this one now, it's a little different because there's no terms to combine. Plus 6, perfect. And then what else? Yes. Very good, girl. That's exactly correct. Very nice.
Yeah, didn't we have that? Yeah, we have it. Like the first one.
Okay. All right. All right. 19. Justice, tell me what to do.
So you plus 3.
Plus 3.
On both sides.
Shh, shh, shh.
And then you add 6x.
Good.
And so you get 2x equals 11.
Wait a
I
minute.
mean, 12. Sorry.
Yes, sir. Don't be sorry. Good.
I think it's right then.
You're done, yeah.
Shh, it's okay, guys.
You divide it, and x equals, is it 6?
Beautiful. X equals 6.
Let's put it,
It's all right.
yeah, that was,
I don't mind the repetition. All right, 21. I'm listening.
So it would be 12 plus
12 plus what?
6
Yes.
equals 9 minus 3.
Very good.
And you subtract 6 1.
Now they kind of tricked you. Yeah, remember I want the variables on the left side, the numbers on the right side.
Oh, okay.
So I would do what?
Plus 3.
Yeah. Plus 3y. And then what?
And then minus 12.
Perfect. So now I have
9y
beautiful.
equals negative 3.
Yep. Now here's the hard part. Most people say negative 3, but we're not going to do that.
But it's 9.
That's exactly correct.
So just 1 third.
That's exactly correct. Now just be careful with the sign, right? Negative 1/3. Is everybody happy with that? Negative 1/3. Are you playing around? All right, 23. Tell me what to do.
Yeah. So, if that right side is plus 4,
Not yet, you don't.
then that is plus 2x.
Nope. Everybody tell them what I have to do first.
Combine terms.
Yeah, Bradley. Combine like terms. So when I combine like terms, what do I get? Negative 3x. Now what do I do? Plus 4. Good job. Then what? Very good. All right, now be careful with this one, okay? What's negative 3x plus 2x? Yes, good job. Is equal to what? 2. Good. All right, now we haven't really talked too much about this. Negative 1x equals 2. You could just say I'm dividing by negative 1. Do you agree? So x equals what? 2 divided by negative 1.
Oh,
You agree with that or not? All right, so I have x equals negative 2. That's kind of tricky. Okay, that was kind of a tricky one. All right, number 25. What do you think I need to do? Minus 3. Plus 6a. 0 equals. So if 0 equals 6, we say 0. No, an identity would be if it's true. No solution. Thank you, girl. Circle with a line through it. That means no solution. right? Everybody happy with that? All right, here we go. Miss Pliego. Tell me about 27, kiddo.
Plus 7
Good job, girl.
plus 7
Very good work.
plus 7 15x equals 5. Wait,
Think about it. Now just relax, kiddo.
15
There you go. So,
x equals 1.
very good. Very good. X equals 1. Now remember, you're supposed to tell me if you're having issues. All right? You may have any issues. All right? I'm trying to get everybody involved. Yosef, I want you to do 29 for me. Good job. Good job. Very good. Good job. Very good. All right, come on, buddy. I'll be happy with you if you get this done now. Yep. Yep. Now, I want you to put the negative out in front, though. Like that. Do you agree? Any issues? All right, Aiden, did you do one yet? All right, you got 31. Carter, I'll let you do 33.
So you do 2 6
Yes? Yeah, you see that, right? I'll just distribute it. Now, can you look at that and tell me that's a what? Yeah, 0 equals 0, right? But more importantly, I want you to be able to tell me what is this called, though? Yeah, it's called an identity. You can see it, right? It's the same thing, right? So we say it's an identity, but I don't really want you to write an identity. I want you to write that. It means all real numbers. That means no matter what number you plug in, it's going to come out to be true. All right? Some equations have no answers. All right? Some equations have 1. All right? Who's up? Who did I say was doing 33? All right, Carter.
So it would be 3x plus 6
Good.
equals -5 minus 2, or no, minus 2x
Good job.
minus 6,
Not minus 6.
or plus 6,
You see why, right?
because like it's a negative 2 and it's negative.
Yep. Negative times a negative is a positive. Now, just give yourself a heads up now. If you need to, do you do -5 minus 2 and get -7 here? No, never, never, never. The multiplication comes before we do the addition and subtraction. Everybody agree with this? You have to distribute the -2 first. You have to distribute the -2 first. All right?
And it'd be -6.
So now I have 3x plus 6.
Oh, yeah. So
Now, here's what I'm trying to show you now. Highlight. I have to combine like terms. What's the matter?
I'm confused why you have the plus 6 on the left side.
3 times 2 is 6, isn't it?
Oh, yeah.
Right?
or no, positive 1.
Very good. 1.
Minus 2x.
Beautiful. 1 minus 2x.
Then you do minus 6.
Good.
And minus 6. And plus 2x.
Good.
Plus 2x. And 6 is crossed out and 2 is crossed out. So it would be 5x equals negative 5.
Perfect. And so,
X equals negative 1.
very good. X equals negative 1. How much you okay today? Does that make sense to you? Everything's good? All right. Wow. 35. All right, who's going to do 35? The Shieldsman. Good for you, girl. I haven't heard from you.
So we do the sugar 2x and then negative 6.
Now, is it really necessary for these parentheses here, guys? You see what I'm saying? There's no reason for it, right? Because there's no number there. So what I would like for you to do is take your highlighter or your whiteout, because I think that's a silly problem. We don't need that. Does everybody agree with me? Because there's no number in front, so there's no reason for the parentheses, other than to try to throw you off. All right? So now, let's go back. Okay, so now, what do I need to do? Which is what? Now, I want you to read it. Instead of read this first. What is that?
Oh, 6.
Yes. So it'd be x plus 6. Do you agree with that, right? Okay, now what?
Then we do plus 6.
Yep. Mm-hmm. Yep. Yep. Wait a minute. Yes. Do you see that now, right? Now, so that is my answer. Do you agree? Does everybody agree with me? X equals 4. Now, listen, guys. I can't believe how good you did. All right. So, we did so good that I was thinking about changing my lessons and just make you guys do the evens for homework. But I want to do this, guys. I think I would prefer that you just do the odds over. Do you hear what I'm saying? I know some of you that you're like, oh, I don't know what that means, right? The reason I want you to do the odds over is because you have to work out solutions, correct? And I want you to learn to check your work as you're doing it. All right? So I want you to just create a new document, the same exact document. And I know it sounds weird. It's not weird. All right? You need the what? The practice. Do you have the right answers? Yes. So that didn't take us that long. All right? So what I want you to do is I want you to create a new file. If you want, you can do this. This is what I do sometimes. On my notebook or on my file, just go back. You can duplicate it. Right? And then I can go take this, clear page. Clear page. Yes, sir. That is correct. That's correct. Clear the page. Does everybody see what I did there now, right? And now I want you to just do what? Just do the odds over. All right? Is everybody with me on that? So tomorrow when I check your homework, you're going to have what? 2 of the same document. So now look, back to my original. That was the cleared. That was my original with all the answers. You know what I mean? That's what I'd like for you to try, guys. I appreciate your work today, man. That was really good. All right, practice just the odds. Just the odds. All right? Good job. Very, very good. Very good.
We have English or history now.
Wait, what do we have?
Hey, good for you.
Okay.
Thomas?
I didn't know.
Justice, you good today? All right, man. Get that done for me tonight now, Justice. Yeah. Having a little trouble pushing in a chair there?
He gets so off topic so easily. Yeah, we would. Someone would say like Star Trek, and then talk about. Wait, who? Oh my gosh, dude, Emily. She would bring up like we were talking about Columbus' ship, and she goes, "Do you think there were cats on the ship?" That's literally what she said. In 5th grade, that's all she would talk about. Her cat, OJ. OJ on Columbus ship. I have a question. I think OJ died. I think he did die. And during the maybe she doing stuff with the cats. Yeah, and then she would always be so happy. And then one time we were talking about our summer break, and she'd just be like, "My cat died," and everyone would be like, "Whoa."
Bradley's the only one who's laughing.
You're gonna hurt my. I'll finish. Well, guys, we have fun history. Fun history. Fun.
Wait, guys, you have
Fun. No, really.
You're evil.
And for all of the night guy has a rocket lance.
So therefore,
Okay.
Rocket League is real.
That's so easy. Why can't we have that? Yeah.
Those were the good old days.
I
want it!
I miss it.
What grade is this?
That looks fun, actually.
Gummy.
Pre-algebra?
I'm fine with that.
That looks fun to do.
I know. Yeah, that's so easy.
Like,
Yeah, some of you might find that challenging.
Oh, that?
Yeah.
Oh, that's easy.
Yeah, what grade is that?
I forgot how to do like.
Wait, is that the
Why do you
grade?
even have
Algebra.
That makes like 7th grade. You don't have to solve that when you see there's squares on both sides and it's not solution.
Wow, what fun.
No, I was singing that song,
That's stupid.
and I was like, Henry, what is that song? I've never heard that before. I'm like, hey, how do you not know this song? I don't know either. And it's like, wow.
I don't make sense.
Oh my gosh, that's stupid.
I love that. That's literally like my favorite thing all in math.
Oh yeah. Don't make fun of me.
Chapter 7 review. There's like 70 or 80 problems. It's
You
through.
are so mean.
You're welcome.
No, I didn't say thank you, sir.